Hi. Let's look at what I have. This is a three-phase short circuit and here crazy saturated current channels. Let's break down the primary scheme to understand the situation. In this case, the device protects part of the busbar between the power autotransformer and the auxiliary transformer, which is connected to the delta winding. The short circuit was outside the zone, and device worked because current transformer in the second branch was saturated. This case is particularly intriguing as it allows us to observe the actual magnitudes of currents in the second branch and compare them with the reconstructed signal on our website using various algorithms. I will remove all unnecessary things and leave only phase A. Let's look at the values in the undistorted channel. The RMS of the first harmonic is 11,177 amperes. There are 4,335 amperes in the distorted channel. The error is almost 60%. The first step is to choose the channel for restoration. The black line is the restored sine wave. The area where recovery occurs is highlighted in pink. By default, the algorithm called -plus is selected. In this case, the algorithm looks for the zero crossing of the sinusoid, takes the last negative value and the first positive value, and calculates the sinusoid from these 2 points. The choice of these points is determined by the nature of the saturation of the current transformers. In the region of the zero crossing, the current shape is transmitted with the least distortion. The restored RMS value is located at the bottom and is called RMS restore. I'll remove the vector diagram window. As you can see, the algorithm does not adequately construct a sinusoid everywhere, but incorrect cases are easy to reject. Let's look at the values here. Undistorted channel 10819 amps. Restored value 10,289 amps. The error is approximately 5%. Moving on to the cursor-based algorithm, you place the cursor where distortion seems minimal, and the algorithm calculates a sine wave from that point. There is also a good result in this place. And at the very beginning of the process the error was 16%. The last algorithm is called amplitude. In this case, the algorithm finds the maximum value and calculates the sinusoid as if it is an amplitude value. There are good results here too, but the error is larger. In general, I would like to note that the nature of saturation of current transformers can be different and in some cases this algorithm works better. We're keen on improving signal shape reconstruction accuracy and are exploring the use of artificial intelligence. If you encounter similar cases or have data that could contribute to our training, please share. Your contribution will boost your karma. Peace to everyone. Bye.